And welcome to part 3 of 6.2. We're talking about ellipses. This next problem says, write an equation for the given ellipse that satisfies the following conditions. A center of 5, 4. The minor axis is vertical with length 16 and c equals 7. So here's the thing. If the minor axis is vertical, that means the major axis is horizontal. So the longer axis is going to be horizontal, and the smaller axis is going to be the minor axis. And this says this is a length of 16. So this entire length of this axis is 16. And so that means that this part is 8 and this part is 8. Is that okay so far? The entire length of the minor axis is 16, so we have 8 and 8. Now remember, since this is the smaller axis, this is the b value. And so b equals 8. Now, why did I go through that long explanation? We're almost ready to go. Like, if you want to write the equation, it's going to be a fraction plus a fraction equals 1. And it's going to be x something squared, y something squared. Okay? So, because the center is 5, 4, it's going to be x minus 5, y minus 4. So that's not too bad so far. Now, we know that we just figured out, we need to figure out what these two numbers are, and we only know b, which we just figured out now. But now we can figure out what a is because we know c and b, and so we can use that equation we did in the last video to find out what a is. Okay, now we know that b is equal to 8, and the smaller axis is up and down, so that means that this is going to be 8 squared. Or if you want to, you can write 64 underneath there. Okay, so now let's figure out, because remember this is the b value, here's the a value, and the equation is c equals the square root of a squared minus b squared, where a is the larger number. If you square both sides of that, you can make it more useful for this problem. C equals a squared minus b squared, so I just squared the left, which made c squared. I squared the right, which got rid of the square root. So here's another, this is a more common thing you might see in textbooks than my version. I use this version because I find a lot of problems you have to solve for c, but in this case they told us c. So let's plug it in. C squared is 7, so 7 squared equals a squared, the number we want to find, the larger number, minus b squared, which is 64, or just 8 squared. So we get 49 equals a squared minus 64 plus 64 plus 64. So a squared equals 49 plus 64, which is 113. And I actually don't need to take the square root here, because remember, this is a squared right here. It's not a. And so this length is the square root of 113. Okay, that's how much this length is. But in the actual formula, I just put a squared exactly. And so the final answer is x minus 5 squared over 113 plus y minus 4 squared over 64, which is b squared, is equal to 1. And that's it. That's a 113. So just remember, a squared and b squared in the formula. When you're graphing, it's a and b without the square. Okay, the next problem says find the eccentricity of the ellipse. Eccentricity is a number that kind of tells you how elliptical something is. So for example, the eccentricity of a circle is 0 because it's a perfect circle. As the ellipse gets more elliptical and more stretched out, the eccentricity goes from 0 to 1. And then when the eccentricity hits 1, you actually have a parabola. So a parabola has an eccentricity of exactly 1. And then if you go more than 1, it actually becomes a hyperbola, which we will see in section 6.3. So here's the formula you need to know for elasticity. E is equal to 1 minus b squared over a squared. And this is for an ellipse. For an ellipse, it's 1 minus b squared over a squared, and this needs to be positive so that the square root is positive. So again, a needs to be the bigger number so that this fraction is less than 1. Okay? Now, by the way, if you rearrange this side, this is actually equal to c over a, which is kind of cool. So if they tell you C, it's a lot easier. You just do C divided by A, and that will tell you the eccentricity. But we don't know C in this case, so we'll just use this formula right here. So the larger number is 16, so that's A squared, which I'm going to put in the bottom. So E equals the square root of 1 minus A squared in the bottom, B squared in the top. Again, notice I just put 16 and 12 because this is B squared and this is A squared. So now you can just crunch it out. So 1 minus 12 over 16, 12 divided by 16 equals 0.75. So it's the square root of 1 minus 0.75, which equals the square root of 0.25. And I believe the square root of 0.25 is a half. Let's see. Yep. Now, if you want to know how I did that in my head, 0.25, remember, is 1/4. And so I did the square root of 1/4 in my head, which is, of course, a half. So the eccentricity of this ellipse is 0.5 or a half. And that's it. So make sure you have this formula down. It's a little bit different formula for a hyperbola. Basically, instead of a minus, it's a plus right there. It's a little different, so we'll take a look at that. This last problem is a little bit tricky, so let's finish that up in part 4. Hopefully eccentricity makes sense to you. If you have any questions, leave them in the comments, and I will see you in the last part of 6.2. See you there.